So we'll do integration revision today. So 7.1 question number 6, integral 4 into e power 3x plus 1 into dx. Excuse me. So you can integrate this with help of a distributive property. First you can split them into two parts, 4 into e power 3x dx plus 1 into dx. So 4 into e power 3x can be written as 4 times of e power 3x dx plus 1 can be written as x power 0 because anything power 0 is 1. And what is integral e power nx dx now?
E power nx.
E power nx upon n.
Upon n, yes.
Upon n plus c. Okay. So
Yes.
here the value of n is 3.
Okay.
So it will become 4 into e power 3x upon 3.
Okay. So we are using chain rule here, Nama. So we are differentiating this, integrating this 3x also. So instead of multiplication and differentiation,
We do
we are
perform
dividing
division here.
integration.
Yeah.
Yes.
So for this x power 0, you have to use x power n rule. So x power n integration is x power n plus 1 upon n plus 1. So x power 0 can be written as x power 0 plus 1 upon 0 plus 1, which is x power 1 by 1. So that would give you x.
Yes.
So that is x. So at last, in the indefinite integral, they didn't mention any limit over here. So you have to put plus integral constant c. That's all about it.
Okay.
I hope it is clear. We'll move to the next question.
Yes, ma'am. Yes.
So the question number 7. It's x square into 1 minus 1 upon x square dx. So here, let's simplify this expression first before proceeding the integration. Just take the x square inside and do the multiplication with this for the further simplification. X square into 1 can be written as x square, and x square into 1 by x square can be simplified as 1. So you will be left with x square minus 1 alone. So when you integrate this, you have to rewrite this 1 as x power 0. Since we are integrating in terms of x, you have to rewrite this 1 in terms of x. So anything power 0 is 1 only. So x power 0 can be written as 1. So again, this has the resemblance of this, which is x power n dx, which is x power n plus 1 upon n plus 1. So x power 2 dx can be integrated as x power 3 upon 3. And when you integrate x power 0, you'll be getting the result as x. At last, you have to include plus c.
Plus c.
Okay, we'll move to the next question.
Yes.
So question number 8. This is also kind of same question. Here you do have few constant in the multiplication. You just keep the constant as it is. You don't have to do anything with the constant. Here you do have a into x square plus b into x plus c into dx. So a into x square. Just keep the a as a itself and integrate the x square alone. When you integrate x square, it will turn into x cube upon 3. Similarly, keep b as b itself. The constant is in multiplication, and when you integrate x can be assumed as x power 1, isn't it?
Yes.
So when you integrate this, it will become x power 2 upon 2. And integration of c. What is integration of c? C can be written as c into 1. At the same time, 1 can be written as c into x power 0. So when you integrate x power 0, you'll be left with x. Okay?
Yes.
So we don't have to use the repeated alphabet for the integral constant, which is why we are using the different variable over here.
Okay.
That's it. B. It's 2x square plus e power x. So integration of e power x is e power x only. Integration of 2x square. Here the 2 is in multiplication. So just keep the 2 as it is. And the integration of x square will give you x cube upon 3. So it's going to be 2 by 3 into x cube plus e power x plus c.
Okay.
Okay. So integral square root of x minus 1 upon square root of x minus the whole square. So this remains This reminds us the formula of a minus b the whole square structure. So you can use this algebraic identity for expanding this, which is a square plus b square minus 2 into a into b. So if you compare this question with your identity, we can conclude a is square root of x and b is 1 upon
1 by
root x. So if you substitute in this, a square will turn into square root of x the whole square and b square is nothing but 1 upon root x the whole square minus 2 into a into b. So it's 2 into a into b. Isn't it?
Yes.
So you can
Yes.
make the cancellation since root x and 1 by root x are in multiplication. And root x the whole square. When you square the root, it will turn into a real value, which is x. So 1 upon root x the whole square can be written as 1 upon x. And you have minus 2 into 1, which can be written as minus 2. So we expanded this expression as x plus 1 by x minus 2. So now we are going to perform integration on this expansion. So when you integrate x, you will be having the result as x square by 2. And integration of 1 by x, there is a formula for the integration of 1 by x, which is log x.
Yes.
And the integration of 2 is nothing but 2 is a constant. So you have to rewrite 2 as 2 into 1. And 1 can be written as x bar 0. Again, the 2 is in multiplication. So just keep the 2 as it is. And when you integrate the x bar 0, you will be getting the answer as x. So it's x square by 2 plus log of x minus 2x plus c. Okay. We'll move to the next question.
Yes.
So x cube plus 5x square minus 4 upon x square dx. This is also same kind of question. The only thing is you just have to simplify this before proceeding the integration. So here this x square is common for all the 3 terms. You can split them into 3 terms by using the distributive property. X cube by x square plus 5x square by x square dx
Yes.
minus 4 upon x square dx. So x
Yes.
cube by x square can be written as x, isn't it?
Yes.
And x
Yeah.
square will get cancelled. You'll be left with 5 alone. And 4 upon x square can be written as 4 into x bar
4
minus 2.
minus 2. Yes.
So now you know how to solve this. 5 can be
Yes.
written as 5 into x bar 0. And x can be integrated with
yes.
help of the power rule, which is x bar n plus 1 upon n plus 1.
Yes.
Okay, you are aware of this. We'll move to the next question.
Yes.
Okay, this is also same kind of question. In this question, the only twist is you just have to rewrite the square root of x as x power 1 by 2.
1 by 2.
Okay, this x power 1
Yes.
by 2 is common for all the 3 terms. So you can rewrite this as x power 3 upon x power 1 by 2 plus 3x upon x power 1 by 2 plus 4 upon x power 1 by 2.
1 by 2.
So we just have to simplify this. Let's simplify 1 by 1. X power 3 and x power 1 by 2. Just take this x power 1 by 2 to the numerator. So you can write it as x power 3 minus 1 by 2, isn't it?
Yes.
How will you simplify this?
1 by 2, ma'am. So 1 by 2, yes. Answer. And
No.
taking LCM.
What is 3 minus 1 by 2? When you take LCM, it will become 6 minus 1 by 2, which is 5 by 2, isn't it?
5 by 2, sorry. Yes.
3 2s are 6. 6 minus 1 by 2 will give you x power 5 by 2.
Yes.
So x power 5 by 2. X power 5 by 2 is the simplification for the first one. And for the second one, it's 3x upon x power 1 by 2. So you can rewrite that as 3x into x power minus 1 by 2. And which can be written as 1 minus 1 by 2. 1 minus 1 by 2 is nothing but 1 by 2.
1 by 2.
So 3 into x power minus 1 by 2. You can write it as 3 into x power minus 1 by 2. You can always keep the constant outside of the integral symbol. Plus 4 upon x power 1 by 2. So this can be written as 4 into x power minus 1 by 2.
Ma'am, how come it is minus 1 by 2, ma'am?
You're just taking into a
No, ma'am,
numerator.
previous term.
What is 1 minus
It is
1 by 2?
1 minus 1 by 2 is plus 1 by 2.
Oh, yeah, it's plus 1 by 2. I'm sorry, it's my bad. It's plus 1 by 2.
Yes. Yes.
Okay. So you just have to again integrate this using the power rule, which is integral x
Yes,
power n. Okay.
Yes.
We'll move to the next question. Question number 13.
Okay.
So this question, x cube minus x square plus x minus 1, a cubic equation upon an expression x minus 1. So we have to integrate this. So before we proceed integration, we have to simplify the numerator, the cubic equation.
Yes.
Okay. So the cubic equation can be simplified as x cube minus x square. You just check the common thing present in the first two terms. X cube can be expressed as x into x square, isn't it?
Yes.
So from the first two term, you can take x square as common. You will be left with x and this will turn into 1. So you can rewrite the first two terms as x square into x minus 1.
1.
Okay. So you have x minus 1 here. They just wrote x minus 1 as 1 into x minus 1.
Okay.
And again, if you check the numerator, you can find x minus 1 expression as common. So from this, you can take x minus 1 as common now. So if you take x minus 1 as common, you'll be having x square and 1. You're getting it?
Yes, ma'am. Yes, got it.
So x square plus 1 into x minus 1 upon x minus 1. We are doing this just to simplify this so that you can cancel out the x minus 1 present in the denominator as well as in the numerator.
Yes.
Okay. So x square plus 1 is the simplified equation. So now we have to integrate this. When you integrate x square will turn into x cube upon 3, and integration of 1 is nothing but x. At last, you have to include plus c as the integral constant because it is a indefinite integral.
Okay. Yes.
Okay, we'll move to the next question. This is also the same kind of question. You just have to rewrite the square root of x as x power 1 by 2. Take the x power 1 by 2 inside and do the multiplication, simplify, and then you will be applying the power rule again for the integration.
Okay. Okay, ma'am. Yes.
Question number 15 is also the same kind of question. Just change the square root of x as x power 1 by 2. And just this x power 1 by 2 is common for all the three terms. Take it inside and multiply them individually. And then you add their power. And then you will be using the power rule for the integration. The same x power n rule. Okay?
Okay. Yes.
Okay, here. So here they are using a trigonometric ratios also. So it's 2x minus 3 cos x plus e power x dx. And integration of 2x is, it's 2 into x, isn't it? So 2 into x means, just keep the 2 as it is, x will turn into x square by 2. This 2 and this 2 will get cancelled out each other. You'll be left with x square. And integral negative 3 cos x. Integral cos x is nothing but sin x. Okay, remember integral cos x is sin x. So just rewrite this integral cos x as sin x. Integration of e power x is e power x only. That is also a formula. At last you have to include integral constant plus c.
Okay.
Number 17. Question number 17 is also similar. You just split them into 3 terms by using the distributive rule. For the first one, you will use power rule. And for the second one, when you integrate sin x, you will get the answer as minus cos x. And 5 root of x can also be written as 5 into x power 1 by 2. Again, for the x power 1 by 2, you will be going for the power rule, which is x power n rule.
Okay. Done.
So for this, okay, this is antiderivative. It's not required.
Okay.
The next exercise. Okay, 7.2, question number 1.
Yes, ma'am.
It's
Yes,
2x upon 1 plus x square. So now we are going to use a substitution method. Okay. So 2x upon 1 plus x square. So in this, we will be performing 3 steps. Okay. The step 1 is assignment. Okay. So you just have to assign an expression or equation to a variable. So over here, you take the denominator 1 plus x square and assign the equation to a variable. I'm assigning this 1 plus x square as t here. Okay, that is the step 1. In step 2, we are going to perform differentiation. We are going to perform differentiation both the side with respect to x.
Okay.
So when you differentiate t, you will write it as d by dx of t, which can be written as dt upon dx, isn't it? And differentiation
Yes.
of 1 plus x square can be written as d by dx of 1 plus x square. And then you perform the differentiation after distributing them. And what is the differentiation of a constant? 0. Differentiation means it's changing. You cannot change the constant. 1 is 1 only. So the differentiation of 1 will give you the result as 0. How? 1 can be written as x bar 0.
X bar 0.
And we know the
Yes.
formula for the differentiation x bar n. Differentiation of x bar n is n into x bar n minus 1. So now you can write it as, when you differentiate x bar 0, it will become 0 into x power 0 minus 1. So 0 into anything is 0 only. So the entire thing will turn into 0, isn't it? So that is how the differentiation of constant is 0. And what is differentiation of x square? Again, the same rule. D by dx of x bar 2 will give you 2 into x bar 2 minus 1. So it will be 2 into x bar 1, which is 2x. Okay. So it's 0 plus 2x is equal to dt by dx. Understood?
Okay. Okay, ma'am. Yes.
So 2x is equal to dt by dx.
Yes, ma'am.
2x is equal to dt by dx. So
Yes.
we can write this as dx is equal to dt upon 2x. Understood? So we perform the second step also. Now we are going to perform the step 3. In step 3, we are just going to change the question, which is in terms of x into in terms of t. Okay, we are just going to change the variables x into t. So let's figure it out. You have 2x upon 1 plus x square. So first, let's write the question. So it's 2x upon 1 plus x square integral dx. This is how we'll represent the question. So 2x upon 1 plus x square. What is 1 plus x square? We assumed 1 plus x square is t.
T.
Okay.
Yes.
So just put t.
Yes.
And what is dx? Dx is dt by 2x. So just write dx as dt by 2x. Okay.
Yes.
So now you can
Yes.
simplify this by cancelling out the 2x in the numerator with the denominator. So we finally converted the question in terms of t now. That is our step 3. In step 1, we did assignment. In step 2, we performed differentiation with respect to x. In step 3, we converted the question in terms of t. Okay. We are done with the substitution method. So now we are going to perform integration. Okay. So integration of 1 by 2, 1 by t dt. What is integral 1 by t?
Log of modulus of t, ma'am.
Log modulus of t. Log of t. Okay. So log of t plus c. So log of t, again, this we converted this question in terms of t for our convenience. So again, we have to convert this question in terms of x. So you have to give the result in terms of x, since the question is asked in terms of x. Okay. So what is t? T is 1 plus x square, isn't it?
1 plus
So
x
the
square.
answer is log of 1 plus x square plus c.
Okay.
We'll move to the next question.
Yes.
Okay, same kind of question. Log x the whole square upon x. Again, log x can be assumed as t. That is the first step. Okay. So when you differentiate both the side, differentiate log, differentiate t. So this will turn into dt by dx. And log x differentiation is nothing but 1 by x.
Yes.
So you can rewrite this as dx is equal to dt into x. Isn't it?
Yes, ma'am. Yes. Okay.
So we performed step 1, step 2. Also in step 3, we are going to change our question in terms of t now. So this is our question. Log x the whole square upon x into dx. What is log x the whole square? Log x is nothing but t square upon x into dx. Dx is nothing but dt into x. So just cancel out the x. So you'll be left with t square into dt.
Yes.
And t square, integration of t square is nothing but t cube by 3 plus c. Understood?
Yes.
So we performed integration. After performing the integration, we have to again rewrite the t in terms of x. What is t? T is log x. So it will be log x the whole cube upon 3 plus c.
C. Yes.
It's 1 upon x plus x log x.
Yes.
So before proceeding this question, we have to simplify this. From the denominator, you have to take x as common and you'll be having another expression which is 1 plus log x. So now you can take this expression, this 1 plus log x as t, and you differentiate both the sides. So when you differentiate both the sides, what will happen? This 1 will turn into 0. This log x will become 1 by x. This t will turn into dt by dx. So now you can rewrite this as dx is equal to x into dt. Now we can convert the question in terms of t. So it's 1 upon x into 1 plus x, 1 plus log x dx. So 1 upon x, you just write it as it is. And 1 plus log x is nothing but t. And dx can be written as dt into x. This x and this x will cancel out each other. You will be left with 1 upon t. And integration of 1 upon t is nothing but log t.
Okay.
So again, you have to put back the t as 1 plus log x. So it's log of 1 plus log x plus c. That's it.
Yes.
Okay. So now we do have some trigonometric functions for the substitution. So it's sine x into sine of cos x. So now they chose cos x as t. Cos x is t, and when you differentiate cos x, differentiation of cos x is negative sine x. You should be aware of the formula. And differentiation of t is dt by dx, and dx can be written as dt upon negative sine x. Okay. So now you just change the question. So just write sine x as sine x, and sine of cos x can be written as sine of t, because cos x is t, isn't it? And what is dx? Dx is dt upon negative sine x. So sine x and sine x will cancel out each other. You will be having minus sine t dt. So what is integral sine t?
Integral sine t is minus cos t.
Minus cos t. So you have minus already. Minus of minus will give you plus. So that would give you cos t. Cos t plus c. And what is t? Again, we have to substitute the t in terms of x. What is t? T is cos x, isn't it? So cos of cos x plus c is your result.
Okay.
You can use any variable for the integral constant. It is not compulsory to use k. You can use any alphabet.
Okay.
This is also same kind of question. You have sin ax plus b and cos ax plus b. So let's assign sin of ax plus b as t. So we are going to differentiate here. Here we will be using the chain rule. Okay. They've shown. Okay. So when you differentiate sin theta, what is differentiation of sin theta? It's cos theta, isn't it?
Cos theta.
So just assign theta as ax plus b.
Yes.
Theta as ax plus b. So sin theta differentiation is cos theta. We're done with that.
Okay.
And then you have to differentiate your assumption, and that needs to be multiplied with your answer. So it's d by dx of theta. What is theta? It's ax plus b. So d by dx of ax plus b. So d by dx of ax plus b can be written as d by dx of ax plus d by dx of b. We are differentiating with respect to x, isn't it? So a is considered to be a constant. So you'll be having a. Differentiation of x is nothing but 1. And what is differentiation of b with respect to x?
0.
It's 0. Yeah.
Yes.
So the answer is a only.
Okay.
So differentiation of ax plus b is a. So it's going to be a into cos ax plus b equal to dt by dx. And dx can be written as dt upon cos of ax plus b. Clear?
Okay. Okay, ma'am. Yes.
So let's change the question. So sin of ax plus b into cos of ax plus b into dx. And sin of ax plus b is nothing but t. Substitute as t. And write the cos ax plus b as cos ax plus b itself for the cancellation purpose. And what is dx? Dx is dt upon a into cos of ax plus b. This cos ax plus b and this cos ax plus b will cancel out each other. And you will be left with t into dt upon a. Take the a outside, which is 1 by a. So you'll be integrating the t alone. Integration of t is nothing but t square by 2, isn't it? T square by 2. And what is t? T is nothing but sine of ax plus b. So t square is sine square ax plus b. Understood?
Yes, ma'am. Yes.
Here they are just rewriting the sine square in terms of 2 thetas. And sine square theta can be written as 1 minus cos 2 theta by 2. That is a formula for cos 2 theta. Cos 2 theta is equal to 1 minus 2 sine square theta. So just take this 2 sine square to the other side and change the cos 2x to this side. So sine square x is equal to 1 minus cos 2x whole divided by 2. Yeah. So just change this sine square as 1 minus cos 2 divided by 2, and x is nothing but ax plus b.
Okay.
Understood?
Yes, ma'am.
That's all about this.
Okay.
So square root of ax plus b. Here also we are going to use the substitution method. We are taking the expression ax plus b and we are assigning it to the variable t. So ax plus b is t. You have to differentiate it both the sides. Differentiation of ax is a. Differentiation of b is 0. Differentiation of t is dt by dx. So a is equal to dt by dx. Dx can be written as dt upon a. So now let's change the question. Just putting the values of t over the question. It will turn into integral square root of t. Dx can be written as dt by a. Just take the a outside, which is 1 by a. T is nothing but square root of t is nothing but t power 1 by 2. So you can use the power rule, which is x power n dx. So you can just increase its power by 1. Similarly, the denominator also has its power and increased by 1. So it's t power 1 by 2 plus 1 upon 1 by 2 plus 1. So it's t power 3 by 2 upon 3 by 2 plus c. Again, we have to put back the value of t in terms of x. T is ax plus p. That's it.
Okay.
Simple. Question number 7. Question number 7 is also same kind. Here you will be taking the x plus 2 as t and you will perform the differentiation.
Okay. Okay.
Same method.
Okay.
Question number 8. In question number 8, we have taken 1 plus 2x square as t and we are performing the differentiation. 2 times of x square. When you differentiate this, we'll be having 2 into 2x, which is 4x. 4x is equal to dt by dx. And you can write this as dx is equal to dt by dx. Let's change the question in terms of t. So x can be written as x itself. Square root of 1 plus 2x square can be written as square root of t. We're just replacing this as t. And what is dx? Dx is dt by 4x. Cancel out the x. You'll be having 1 by 4 into integral square root of t dt. And what is square root of t? Square root of t is nothing but t power 1 by 2. So again, we'll be using the power rule for the integration. So it will become t power 1 by 2 plus 1 upon 1 by 2 plus 1, which is t power 3 by 2 upon 3 by 2. Again, putting back the value of t over here, which is square root of 1 plus 2xt square. Not square root, just 1 plus 2x square, I'm sorry. This question. You have an expression and a quadratic equation under the square root. So take the quadratic equation and assign it to a variable t and differentiate both the sides with respect to x. Change them in terms of t. It's very simple. Again, we'll be using the power rule only for the integration.
Okay.
Question number 10. It's 1 upon x minus square root of x. So here, the trick is to rewrite the question. And x can be written as root x into root x. Okay.
Yes,
so it's 1 upon root x into root x minus root x.
Okay.
Here, the thing is, whenever you find the denominator in the form of an expression, in the expression always you'll be having 2 terms with addition or subtraction, isn't it? So you have to change your denominator in terms of factors. It should be in the form of multiplication. For that purpose only, we are rewriting the x as square root of root x into root x. Okay. So when you take square root of x outside, you'll be having square root of x minus 1. So now you can see the 2 factors in multiplication, root x and root x minus 1. So we're just changing the sum of the terms into product of the terms. Understood? That is the key here.
Yes.
So we are changing the sum of the terms, which is in the denominator, to the product of the terms in the denominator. So once we are done performing that, we can go for the substitution method. In substitution method, you take an expression. So if you are getting confusion whether to choose this root x as t or root x minus 1 as t, always give priority to an expression. If you find expression and a quadratic equation, you give priority to the equation. Always give priority to the higher degrees. Okay. So here you can take the expression square root of x minus 1 as t here. Okay. Again, you have to substitute both, differentiate both the sides. Just differentiate your question. After differentiating, change the question in terms of t and then you do the integration. Again, you substitute back. Putting the value of t as square root of x minus 1 will give you the result.
Okay.
Same method. The only thing is you're changing the sum of the terms into the product of the term in the denominator. That is the only twist in that question. So this question, x upon square root of x plus 4. So here we are adding and subtracting plus 4 in the numerator.
Yes, ma'am.
Okay, so now we are going to split this as x plus 4 upon square root of x plus 4 and minus 4 upon square root of x plus 4, because the square root of x plus 4 is common for all the three terms present in the numerator.
Yes.
Okay.
Yes, ma'am.
And you can write a plus b plus c as a plus b plus c, or else you can club b plus c also. It's your wish. Okay.
Okay, ma'am. Okay.
It's just associative property. This integration supports associative rule, so you can combine anything. It's your convenient only.
Okay.
Why I'm taking x plus 4? Because x plus 4 can be written as square root of x plus 4 into square root of x plus 4. In the denominator, you do have another square root of x plus 4. So this square root of x plus 4 can make cancellation with the square root of x plus 4 in the denominator. That is why I'm grouping the x and 4 together.
Okay, ma'am.
So square root of x plus 4 can be written as x plus 4 the whole power 1 by 2, isn't it?
1 by 2. Yes, ma'am.
Square root of x plus 4 has written as x plus 4 the whole power 1 by 2. And over here you do have x plus 4 in the denominator, which can be written as 1 by 2. So when you take the denominator to the numerator, the sign of the power will change. So the plus 1 by 2 will change into negative 1 by 2. So it's 4 into x plus 4 whole power negative 1 by 2. So now we are going to perform integration. So x plus 4 the whole power 1 by 2 can be integrated as x plus 4 whole power 3 by 2 upon 3 by 2. And this x plus 4 whole power negative 1 by 2 can be written as x plus 4 whole power negative 1 by 2 plus 1 upon negative 1 by 2 plus 1. Clear?
Okay, ma'am. Yes, ma'am. Clear.
This 1 by 2 can be written as square root.
Okay.
They are taking this 2 times of x plus 4 power 3 by 2, 1 by 2 as common, but you don't have to do it. You don't have to do it. This is fine.
Okay. Okay.
It is not compulsory.
Okay, ma'am.
X cube minus 1 the whole power 1 by 3 into x power 5. Okay. Here also we are going to use the substitution method. Here we are taking x power 3 as t and we are differentiating. Differentiation of x power 3 is 3x square. You know the rule. Differentiation of x power n is nothing but n into x power n minus 1, isn't it? So differentiation of x cube is 3 into x power 3 minus 1, which is 2. So it's 3x square. So 3x square is equal to dt by dx, and dx can be written as dt upon 3x square.
Yes.
So now let's change the question in terms of t.
Yes, ma'am.
So this is our question. We are changing the x cube as t. And minus 1, just write minus 1 as it is. Whole power 1 by 3. And x power 5 can be written as x power 3 into x power 2, isn't it?
Yes, ma'am. Yes.
So we are just splitting the x power 5 as x power 2 into x power 3. And what is dx? Dx is nothing but dt upon 3x square.
3x square. Yes, ma'am.
Okay. So now you can cancel out the x square in the numerator and x square in the denominator. I mean, this x square and this x square can be cancelled out. So it's t minus 1 the whole power 1 by 3 into x cube upon 3 into dt. Because x cube can be replaced as t.
Okay.
So now we have changed our entire question in terms of t.
Okay, ma'am. Okay.
So here we are adding and subtracting 1. We are adding and subtracting 1 in this question.
Okay, ma'am. Okay.
Now what we are doing, you are just taking this t minus 1 the whole power 1 by 3 to these two terms and multiplying. So
Okay.
t minus 1 power 1 by 3 into t minus 1 can be written as t minus 1 the whole power 1 by 3 plus 1, isn't it?
Yes, ma'am. Yes.
Because we have the same base, you just have to add the powers. Here
Yeah.
the power to the t power minus 1 is nothing but 1. And what
Okay.
about this? When you multiply t minus 1 the whole power 1 by 3 to this, it will be t minus 1 the whole power 1 by 3.
1 by 3. Yes. Got it.
And when you integrate this, okay, before integration, they have taken LCM here. 1 by 3 plus
Yes,
1 can be written as 4 by 3. Okay.
Yes.
And when you
Yes.
integrate by using the power rule, it will become t minus 1 whole power 4 by 3 plus 1 upon 4 by 3 plus 1.
3 plus. Yes.
Yeah. And this 1 by 3 will be 1 by 3 plus 1 upon 1 by 3 plus 1.
Okay.
We're just using the power rule here.
Okay, ma'am. Yeah.
4 by 3. That's it. After
Okay.
after this LCM, we're just substituting the t as x cube.
Okay.
X square upon 2 plus 3x cube the whole cube. So in this question, we are taking the denominator 2 plus 3x cube as t, and we are differentiating both the sides. And when you differentiate 3x cube, what is the differentiation of 3x cube?
3x cube is 9x square, ma'am.
9x squared, isn't it? So you will
Yes.
take the 3 outside, it is in multiplication. And differentiation of x cube is 3 into x power 3 minus 1, which is 2.
Yes.
By using the power rule.
Yes.
N into x power n minus 1 rule.
1.
Okay. So t turned into dt by dx.
Yes.
So just switch their position. Dx is equal to dt upon 9x square. So now let's change the question in terms of t.
Okay.
So just write x square as it is, and 2 plus 3x cube, the whole cube is nothing but t cube. And what is dx? It's dt upon 9 into x square. X square and x square will be cancelled. It's dt upon t cube. So just take the t cube to the numerator, it will turn into t power minus 3 dt. So again, you will use the power rule for the integration. It will turn into t power minus 3 plus 1 upon minus 3 plus 1. Substitute back the t. What is t? T is 2 plus 3x cube. So it will turn into 2 plus 3x cube, the whole power minus 2 upon minus 2 plus c. Okay?
Yes. Now what happens to its 9? Now 9 comes outside.
Oh yeah.
Yes.
Oh yeah, 9 will multiply with the negative 2, it will turn into negative 18.
Okay, ma'am. Done.
So many questions. Okay. It's 1 upon x into log x the whole power m, x is greater than 0. So again here we are assigning log x as t, and differentiation of log x is nothing but 1 by x. And what is t? Differentiation of t with respect to x is nothing but dt by dx. So take the dx to the other side and x to this side. Dx is equal to x into dt. So putting log x as t and dx as x into dt, it will fetch you this. Just cancel out the x and x. It's 1 upon t power m into dt. So take the t power m to the numerator, that will turn into t power minus m into dt. So when you integrate this, t power minus m plus 1 upon minus m plus 1 by using the power rule. Okay. Sometimes the power
Okay.
can be a variable also.
Okay, ma'am.
Again, you putting back t as log x. So it's
Log
log x
x.
whole power 1 minus 1 upon 1 minus 1 plus c.
Okay.
Question number 2, x upon 9 minus 4x square. So here you are taking the denominator as t and you are doing the same substitution method and integrating. So when you integrate 1 by t, you are getting log t. So again, you will be putting back the t in terms of x. Same method. E power 2x plus 3. So 2x plus 3 can be assumed as x. Differentiate both the sides. 2x plus 3 will turn into 2. T will turn into dt by dx. And dx is equal to dt upon 2. So just change your question in terms of t now. It will be e power t. What is dx? Dx upon 2. So take the 1 by 2 outside. When you integrate, I mean, it should be t.
dt, ma'am.
Yeah. So when you integrate e power t, it's e power t only.
E power t only. Yes.
So what is t? Again, we have to putting back the value of t.
2x.
That should be
plus 3.
e power 2x plus 3 plus c. That's your result.
Answer. Okay.
E power 2x plus 3 plus c.
Yeah.
This question is also same kind. You just have to assign x square is t in this and do the same thing.
Okay. Okay, ma'am.
E power tan inverse of x upon 1 plus x square. Here we are having inverse trigonometric function. So we have to know, we should be thorough with the differentiation of inverse trigonometry formula also. So what is tan inverse of differentiation of x?
1 by 1 plus x square. No?
1 by 1 plus x square. Okay.
Yes.
So here you will choose the inverse trigonometric as t. So choose tan inverse of x as t and then you do the differentiation. So if you differentiate both the side, tan inverse of x will turn into 1 upon 1 plus x square and t will turn into dt by dx. And dx is equal to 1 plus x square into dt. Yeah. So now
Yes.
differentiation is done. We just have to change the question in terms of t now. So e power tan inverse of x can be written as e power t 1 divided by 1 plus x square. You just keep it as it is. And what is dx? Dx is 1 plus x square into dt. So 1 plus x square in the numerator and denominator get cancelled out each other and you will be left with e power t alone. So what is integral e power t?
E power t only.
E power t. And then you have to substitute t as tan inverse of x. So it's e power tan inverse of x plus c. That's it. The only thing is you should be aware of the differentiation of inverse trigonometric formula over here. Okay. So in this question, you have e power 2x minus 1 upon e power 2x plus 1. So here we are going to divide the numerator and denominator by e power x, which means you're going to divide all these 4 terms by e power x. Okay. So e power 2x upon e power x, nothing but e power x. 1 upon e power x will turn into e power minus x. And in the denominator, you do have e power 2x upon e power x, which is e power x. 1 upon e power x will turn into e power minus x. Okay. So now we can go for the substitution process. Let's take the denominator as t. The denominator e power x plus e power minus x as t. Differentiate both the sides with respect to x. When you differentiate e power x, what is differentiation of e power minus x?
E power minus x is
minus e power minus e power minus x.
Okay.
Because differentiation of e power nx is nothing but n into e power nx. So e power minus x means the value of n would be -1. So it's minus 1 into e power minus 1x. You don't have to write the 1. So it will be minus e power minus x. Understood?
Yes, ma'am.
So differentiation of e power minus x is minus e power minus x equal to dt by dx.
Okay.
So dx can be written like this. So now we have to change the question in terms of t.
Okay.
So let's change it.
Okay.
We are writing e power x minus x as it is. We have assumed the denominator e power x plus e power minus x as t. So just
Yes,
replace this as t. And what is dx?
Okay.
Dx is dt upon e power x minus x. Okay.
Okay.
So now you can
Okay.
cancel out the e power x minus x and this one.
Okay.
So you'll be left with 1 by t alone. When you integrate 1 by t, the answer is log of t. So
T.
substitute back. What is t? T is e power x plus e power minus x. Let's see.
Okay.
That's it.
Okay, ma'am. Okay. Yes, ma'am.
This question is also same kind of question. Here they directly gave you e power 2x minus e power minus 2x upon e power 2x plus e power minus 2x. You just take the denominator and assign it to a variable, and then you do perform the substitution method and integrate. Okay.
Okay.
Same
Okay.
question.
Done. Okay.
#21. Okay. Here you do have a square trigonometry. Tan square
Okay.
2x minus 3. There is no formula for the integration of tan square. Okay.
Okay.
So you have to use
Okay.
trigonometric identity to find another trigonometric ratio. And tan square
Okay.
theta can be written as secant square theta minus 1, isn't it?
Yes, ma'am. Yes.
Because tan square theta, secant square theta minus tan square theta is 1. So from that you can derive the tan square theta as secant square theta minus 1. So just rewrite the tan square in terms of secant square, because we do have a formula for the integration of secant square. Okay.
Yes,
so it's secant square. What is theta? Theta is 2x minus 3.
Yes, ma'am.
You have minus 1 here. You write that as well.
Yeah. Okay.
So by using the distributive property, you can split the integral for the two term. And what is integration of secant square? Secant square theta.
Tan theta.
Secant square theta is tan theta, but the thing is you do have 2x minus 3 here. You have an expression, not a variable. Okay, so you have to go for substitution. So they are assigning 2x minus 3 as t.
Okay.
And then when you differentiate both the side, 2x minus 3 turned into 2 and t turned into dt by dx, and dx is nothing but dt by 2. So now let's change this secant square 2x minus 3 dx into secant square t dt by 2.
Okay.
So now you can use the formula. Integration of secant square x dx is nothing but tan x. So secant square t is tan t.
Okay.
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 So just replace t as 2x minus 3 again. Okay.
Okay.
So we are done with the first part. And what is the second part? You just have to integrate the -1. So integration of -1 is nothing but just rewrite 1 as x power 0.
Yes.
That would give you x power n plus 1 upon n plus 1 rule, which is x.
Yes.
That's it. So at last you have to club the two parts.
Okay.
Clear?
Yes, ma'am. Very clear.
Okay. This is also pretty easy.
Okay.
So they just gave the partial part of the question number 21. Secant square into 7 minus 4x. You just have to assume the expression as the variable and do the substitution method. And then you use the integral secant square theta. What is integral secant square? It's tan theta, isn't it?
Tan theta.
So you'll be getting the answer in terms of tan.
Tan theta. Okay.
Sin inverse of x upon square root of 1 minus x square.
Yes.
So for this question also we are using the substitution method. Here, always we'll choose an inverse trigonometry as the variable for assigning. Okay, so you can choose sine inverse of x as t. And what is differentiation of sine inverse of x? It's 1 upon 1 minus square root of 1 minus x square.
Square root of 1 minus x square.
So when we differentiate both the sides, you will be getting an expression like this. Take the dx to the other side and square root of 1 minus x square to the right side. And just, we're just done with the substitution. Now we have to substitute our question in terms of t. So it's going to be integral. What is sine inverse of x? It's t, isn't it?
1 minus
square root of 1 minus x square, and dx is square root of 1 minus x square into dt. Cancel out the 1 minus x square in the numerator and the denominator. You'll be left with t alone. When you integrate t, it's going to be t square upon 2. And again, we have to substitute t in terms of x. And what is t? Sine inverse of x. Sine inverse of x the whole square upon 2 plus c is the answer.
Okay.
2 cos x minus 3 sin x upon 6 cos x plus 4 sin x. Okay. So in this, you have to choose your denominator as the t and do the same differentiation. Okay. You should be aware of the differentiation of trigonometric formula. Differentiation of cos theta is negative sin theta, and differentiation of sin theta is cos theta.
It's cos theta.
The rest of the things are same only.
Same. Okay.
Same method.
Yes.
It's 1 upon cos square x into 1 minus tan x the whole square. So we are choosing 1 minus tan x as the t. When you differentiate tan theta, differentiation of tan theta is secant square theta.
Secant square theta. Yes.
So negative secant square x equal to dt by dx, and dx can be written as dt upon secant square x.
Theta.
And they are just rewriting the secant square in terms of cos square because we do have a cos square in our question. So secant square theta can be written as 1 upon cos square x. Denominator to the denominator can be taken to a numerator. So it will become dx is equal to minus cos square x into dt, isn't it?
Yes, ma'am. Yes.
So now let's change our question in terms of t. It's going to be 1 upon cos square x into what is 1 minus tan x? 1 minus tan x is nothing but t.
Yes, ma'am. Okay.
So 1 minus tan x the whole square is nothing but t square. And what is dx? Dx is minus cos square x dt.
Yes.
Okay. So you can cancel out the cos square x in the numerator and the denominator. So you'll be left with minus 1 upon t square into dt. So take the t square to the numerator. It will become t power minus 3. I mean t power minus 2. So when you integrate, you can use the power rule for the integration. It's minus 2 plus 1 upon minus 2 plus 1, which is minus 1 upon minus 1. So it would be minus 1 and minus 1 will cancel out each other. It's t power minus 1, which is 1 upon t. And we know the value of t, which is 1 minus tan x. That's it.
Okay. Yeah.
So cos square root of x upon root x. So we are choosing square root of x as t. So you have to differentiate both the sides. So you will be getting its value as 2t into dt. Okay. So let's change our question. Yes. It will become cos t upon t into 2t dt. So this t and this t will cancel out each other. Cos t into 2 can be written as 2 times of cos t. Take the 2 outside since 2 is a constant. It is a multiplication. And when you integrate cos t, the answer would be sin t. Yeah. And again, you have to put back the value of t, which is root x. So it's 2 sin root x plus c. That's it.
Okay, ma'am.
27. Question number 27, you do have square root of sin 2x into cos 2x. So choose sin 2x as t and do the differentiation.
Yes,
that is also very easy only.
Okay.
Cos x upon 1 plus sin x. Always go for the expression. Take the expression 1 plus sin x as dt and differentiate both the side. You will be having dx as dt by cos x. Just change your question. It's cos x upon what is 1 plus sin x? It's t. Dx can be written as dt by cos x. Cos x in the numerator, cos x in the denominator will cancel out each other. dt upon square root of t. Square root of t can be written as t power 1 by 2. Take it to the numerator, it will become t power 1 minus 1 by 2. So when you use the power rule, it will become t power minus 3 by 2 upon, t power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1, which is t power 1 by 2 upon 1 by 2. 1 by 2 can be written as 2 here. So what is t power 1 by 2? It's root t, and root t is nothing but 1 plus sin x. That's it.
Yeah, yes, got it.
Cot x log sin x. Okay.
Okay.
So they are taking log sin x as t and they are performing differentiation. So you should be aware of the formula. Differentiation of log x is
1 by x.
1 by x, isn't it? So differentiation of log of sin x is 1 upon.
So 1 by sin x into differentiation.
And by using chain rule, you have to differentiate the sin x again. So what is the differentiation of sin x? It's cos x.
Cos x, yes.
Cos x upon sin x can be written as cot x.
Cot x, okay.
That's it.
So you
can. So differentiation of log sin x is nothing but cot x. Cot x is equal to dt by dx.
Dx, okay.
So cot x and cot x will cancel out each other.
Okay, ma'am.
We'll be left with t alone. T square by 2. What is t? T is log of sin x. That's it.
Okay. Okay.
This question also, you just have to choose 1 plus cos x as t and proceed the same method.
Yes, ma'am. Yes. Okay. 1 plus cos.
In this question also, choose 1 plus cos x as t. Always go for the expression and assign.
Okay.
Same method.
Okay. 1 plus cos x also.
It's 1 upon 1 plus cot x. Okay.
Okay, ma'am.
Here we are just rewriting the cot theta in terms of sin theta, cos theta upon sin theta.
Sin theta. Okay.
So after that, we are comparing these two, and since both the denominators are different, isn't it? So you can go for LCM.
Okay.
If you take LCM, it will become sin x plus cos x upon sin x. So denominator to the denominator can be written as the numerator, and it will turn into sin x upon sin x plus cos x. So we are dividing the numerator by 2 and multiplying we are dividing and multiplying it by 2 here. So it will turn into 2 sin x upon 2 into sin x plus cos x. And we also adding and subtracting cos x in the numerator. I'll tell you why.
Okay.
And we are splitting the 2 sin x as sin x plus sin x. Because sin x plus sin x is 2 sin x, isn't it?
Okay.
So now you can shuffle them. Sin x plus cos x, sin x and minus cos x.
Okay.
Okay, we shuffled it and we wrote it here. And now we're just clubbing these two and they're writing it as a fraction, and similarly they're taking these two and writing it as a fraction. So this will be cancelled, we'll be having 1. The numerator and the denominator will be cancelled.
Okay.
So integration of 1 is x. This part is done.
Yes.
So you have to take this part and you have to take it separately and solve it using the substitution method. We'll see how.
Substitution method. Okay.
So the denominator can be assumed as t. Differentiation of sin x is cos x. Differentiation of cos x is minus sin x. T will turn into dt by dx. So dx is nothing but dt upon cos x minus sin x.
Yes. Okay. Yes.
So they're just taking the minus outside. So it will become minus of sin x minus cos x. So now let's change the question. So the question is sin x minus cos x upon sin x plus cos x. So the sin x plus cos x can be written as t. Sin x minus cos x, just write it as it is. And what is dx? Dx is dt upon minus of sin x minus cos x.
Okay.
So sin x minus cos x and sin x minus cos x will get cancelled out each other. You'll be left with this. That is the reason we are taking the minus outside. Okay.
Okay, ma'am.
So when you integrate
Okay.
1 by t, you will be having the answer is log t.
Log of modulus.
Again, putting back
Okay.
the value of t, which is sin x plus cos x.
Okay, okay. Yes,
Understood?
ma'am. Yes, got it.
So at
Yes, ma'am.
last,
Yes.
we're just clubbing the answers.
Okay.
That's it. One minus 1 upon 1 minus tan x. So same method. We
Yes.
are just in the previous question, we changed cot x as cos x upon sin x. Here we are just
Yes.
changing the tan x as sin x upon cos x. Okay.
Cos x. Okay.
Same kind of
Okay,
question.
okay.
Same method.
Okay.
Square root of tan x upon sin x cos x.
Okay.
Here they are multiplying the cos x. They are multiplying the denominator and dividing the denominator by cos x. Okay. So cos x
Okay,
upon
okay.
cos x. This cos x into cos x turned into cos square x. And you have cos x here. Now this sin x upon cos x can be written as tan x, isn't it?
Tan x. Yes, ma'am. Tan x.
So it's square root of tan x upon cos square x into tan x. And again, this tan x can be expressed as square root of tan x into square root of tan x. This square
yes,
root of tan x and this square root of tan x will cancel out each other.
Okay.
Yeah. So just take this tan x to
Yes.
the numerator. It will turn into tan x power 1 minus 1 by 2.
Okay.
And 1 by cos square x can be written as secant square x.
Secant square x. Okay.
So far clear?
Yes, ma'am. Yes, very clear.
So now we are going to use the substitution rule. Okay. We are taking
Okay.
tan x as t, and the differentiation
Okay.
of tan x is nothing but
Tan
secant
x is
square
secant square
x.
x. Yes, ma'am. Yes.
Okay. So secant square
Yes,
x
ma'am.
dx can be written as dt. So just change this into dt. And this
Okay.
will turn into t power minus 1 by 2. You know how to proceed after this.
Yes, ma'am. Yes, sir. I know.
Clear?
Yes, ma'am. Very clear.
One plus log x upon x the whole square. So in this, you have to choose the expression the 1 plus log x as t and perform differentiation both the sides and turn your x question in terms of t and do the differentiation. And do the integration. At last, you have to put back the value of t in terms of x. That's it. Very simple question.
Okay. Okay, ma'am.
This question is also. In this question also, you have to go for this. Choose
Okay.
x plus log x as t and do the differentiation. You'll be able to make the cancellations and do the same substitution method. You'll be getting the answer. It's very simple.
Sharing, ma'am. Done.
Okay. In this you will choose always. You will choose the inverse trigonometry as t, isn't it? We'll give preference to that.
Okay.
So tan
Yes,
inverse
ma'am,
of x
yes.
power 4 will be considered as t. And when you differentiate,
Okay.
differentiation of tan inverse of x is nothing but 1 upon 1 plus x
1
square.
by 1 plus x.
So you will just replace x as x power 4 here, isn't it?
Yes, ma'am.
So
Yes.
since you are making an assumption that you are assuming x power 4 is x here, we'll be using the chain rule for the differentiation.
Chain rule.
You will be differentiating the x power 4 again. You will be getting the answer as 4x cubed.
Okay.
So we are using chain rule for the differentiation. Okay, remember.
Okay, ma'am. Done. Yes, ma'am.
The rest of the things are same only.
Same. Okay.
Okay, this question is also same kind of question. We'll move to the next exercise. Okay. So you have sine square into 2x plus 5.
Okay, ma'am.
So before solving this question, you just have to convert this sine square theta in terms of some double theta. So sine square theta is equivalent to 1 by 2 into 1 minus cos 2 theta, isn't it? This is the
Yes, ma'am.
formula.
Yes. Okay. Yeah, ma'am.
This is the formula.
Yes.
So here theta is nothing but 2x plus 5. So you can
5.
rewrite your question as 1 by 2 into 1 minus cos 2 times of 2x plus 5.
Yes, ma'am.
2 into 2x plus 5 can be written as 4x plus 10.
Okay.
So now you can integrate this using the distributive law. Take the 1 by 2
Okay.
outside. Integration of 1 is x. Integration of
Okay.
cos theta. What is integration of cos theta? It's sine theta, isn't it?
Sine theta.
So
Yes,
sine
ma'am.
theta, sine of 4x plus 10. And when you integrate
Okay.
with respect to x, you will always write the coefficient of x in the denominator.
Denominator. Yes, change it.
So it's sine of 4x plus 10 upon the coefficient of x is 4. So that will be in the denominator.
Denominator. Okay.
Understood?
Yes, ma'am. Yes.
Question number 2. You have a product of two thetas, sine 3x
Okay.
and cos 4x. We don't have any formulas like when here you are having two trigonometric ratios in the form of multiplication, isn't it? We don't have any formula for this. So you have to convert this product of the terms into a sum of the terms. Okay. So in trigonometry, we do have a formula to convert the product of terms into the sum of the terms. Okay.
Yes.
So
Yes.
here you do have a combination of sine theta and cos theta.
Yes.
Yeah.
Ma'am.
So sine A cos B is equal to 1 by 2 sine of A plus B plus sine of A minus B. This is the formula.
Yes.
Okay.
Yes.
So you
Yes.
do have I think eight formula, I guess, in this combination, like sine A
Yes,
cos
ma'am.
B,
Yes, yes.
cos A sine B, like that. No,
Okay,
not cos A sine B. Like sine A sine B, cos A cos B, like that. Okay. So
ma'am.
sine A cos B can be written as 1 by 2 into sine of A plus B plus sine of A minus B. And
Okay.
here the value of A is nothing but 3x. The value of B
Okay.
is 4x. Just replace A as
Okay.
3x and B as 4x in this. Okay.
Okay,
And then you
ma'am.
simplify.
Okay.
3x plus 4x is 7x. 3x minus 4x is minus x.
Minus
And
x.
sine of minus
Sine of-
theta is minus
sine
sine theta. Minus sine theta. So you will be having minus sine x. Printing mistake.
Okay. Okay.
Understood?
Yes, ma'am.
So now we converted the product of the term into the sum of the terms, so that by using the distributive rule, you can do the integration to both the terms individually. You can apply the integration to both the terms individually. Okay.
Okay.
So integration of sine 7x. What is integration of
7x
sine
is-
nx?
Minus
It's
cos
minus
7x
cos
divided
nx
by 7.
upon n, isn't it?
Yes.
So sine
Yes.
7x will turn into negative cos 7x
Fine.
upon 7.
7. Yes.
Okay.
Yes, ma'am.
And integration of sin x is nothing but minus cos x, minus of minus
cos
will
x.
turn into plus cos x.
Yes. Okay.
Give me a second.
Okay, ma'am.
Okay. So question number 3, integrate the function cos 2x, cos 4x, cos 6x. So here we do have 3 trigonometric terms in multiplication. So you have to take first 2 terms and take this first product of the terms and convert this in terms of sum of the terms. Okay. So cos A into cos B can be written as cos A plus B plus cos A minus B by 2. Okay. So you can assign A as 2x and B as 4x. So just substitute A as 2x and B as 4x in this. Okay. So we are just solving the very first 2 terms. Okay. Keep the cos 6x aside. Okay. So cos 2x plus 4x can be written as cos 6x. 2x minus 4x can be written as minus 2x. And what is cos of minus theta? It's cos theta. It will turn into positive.
Okay.
Yeah. So cos of minus 2x can be written as plus cos 2x.
Okay, ma'am.
Okay. So cos 2x, cos 4x is nothing but 1 by 2 cos 6x plus cos 2x.
Okay.
And you have cos 6x here. So now we can include that. So now you take the cos 6x inside and multiply with these two terms. Okay. Cos 6x into cos 6x can be written as cos 6x the whole square. Cos 2x into cos 6x can be written as cos 2x into cos 6x. Okay. So again, we are going to consider this expression as the two individual integrals and we are going to solve it separately. Okay. Let's solve cos 6x the whole square. So what is cos square theta? Cos square theta can be written as cos 2 theta plus 1 upon 2. Here the theta is nothing but 6x. Okay. So cos square 6x can be written as cos 2 times of 6x plus 1 upon 2. 2 times of 6x will give you cos 12x. Can you follow?
Yes, ma'am. Yes.
I'm just rewriting the cos square theta in terms of cos 2 theta. Okay.
Okay.
Cos 2x plus 1 upon 2. Take the 1 by 2 as constant. Integrate the cos 12x plus 1 alone. So when you integrate cos 12x,
Cos 12x will be
cos
sin
12x will
12x
be sin 12x by 12.
sin
The
12x
coefficient
divided
of
by
x will come in the denominator, isn't it, when you integrate it?
Yes.
And different
Yes.
integration of 1 is nothing but x.
X.
That's it.
Yes.
So we are
Okay.
done with the first part. In the second part, again we have to deal with the conversion of product into a sum of the terms. Okay.
Sum.
Here cos 2x
Okay.
and cos 6x are in multiplication. Use the cos A cos B rule, which is 1 by 2
Okay.
cos of A plus B plus cos A minus B, because we don't have any direct formula in integration.
Okay.
Which is why we are
Okay.
converting. Okay. So just assume A as 2x and B as 6x here. Substitute back and simplify. Again, you'll be having cos 8x plus cos of minus 4x, and cos of negative theta is cos theta. So which is cos 4x. Okay. So now the answer is 1 by 2 cos 8x plus 1 by 2 cos 4x. We are not done with the integration. We just applied the trigonometric formula and we expressed it like this. So now you can split them by using the distributive rule. Like cos 8x is nothing but, what is integral cos 8x? Sin 8x upon 8. And integral cos 4x is nothing but sin 4x upon 4. Understood?
Yes, ma'am. Yes.
So sin cube 2x plus 1. So we don't have formula for integral sin cube theta. So you have to convert sin cube theta in terms of 3 sin theta minus sin 3 theta by 4. Okay. We do have a formula for sin 3 theta where you'll be able to find the sin cube theta. So we use the formula and derive the value of sin cube theta. Okay. So now we have to replace theta as 2x plus 1. Just change your question as 3 times of sin 2x plus 1 minus sin into 6x plus 3 upon 4. 3 times of 2x plus 1 will give you 6x plus 3. Clear?
Okay. Yes, ma'am. Yes.
Okay. So after changing it, you can distribute them. Okay. So this 4 is common for both, or else you just take the 3 by 4 is common outside. No, you can't take 3. You can take 1 by 4 is common.
1
So
by
it
4
will be
is
3 times of sin 2x plus 1 and integral sin 6x plus 3. So when you integrate, integration of sin theta is negative cos theta, and you have to put the coefficient of x in your denominator.
Okay.
Similarly, integration of sin 6x plus 3 is cos 6x plus 3 upon 6. The coefficient of 6 will come in the denominator.
Okay.
That's all about this.
Okay.
Here again they have replaced cos 3 theta as 4 cos cube theta minus 3 cos 3. 3 cos theta, which is not required.
Okay.
Sin cube x cos cube x. So
Okay.
here we are going to use the very simple identity. Before we have used 3 sin theta minus 4 cos cube theta. We don't have to use that big formula over here. Just rewrite sin cube as sin x into sin square x and cos cube x as cos cube x itself. You know, sin square theta plus cos square theta will give you 1. So sin square theta can be written as 1 minus cos square theta. Yeah. So now we have changed the question as 1 minus cos square x into cos cube x into sin x dx. Okay.
Okay.
So with this, we will be able to apply the substitution method in this. Okay.
Okay.
Assume cos x as t. Differentiation of cos x will give you negative sin x. Differentiation of t with respect to x is dt by dx. Take the dx to the other side and sin x to this side. Dx is equal to dt upon negative sin x.
Okay.
So just change your question in terms of t. 1 minus t square into t cube because cos theta is t. So cos square x is t square and cos cube x is t cube. And sin x dx. Just write sin x as sin x itself. And what is dx? It's dt by minus sin x.
Minus sin x.
This sin x and this sin x will cancel out each other.
Okay.
And take the minus inside. It will turn into t square minus 1 into t cube. They kept the minus outside. Anything is fine. You just take the t cube inside and do the multiplication. You'll be having an expression like this, and then you do perform integration by using the power rule. Okay.
Yes.
And then you substitute the value of t, which is cos x.
Okay, ma'am. Okay, done.
This one is also similar to the question number 3, like where we do have this 3 cos terms. Okay. So in this, you will be using the product of the terms to sum of the terms. So sin A sin B can be written as 1 by 2 minus cos of A plus B plus cos A minus B. Okay, you take the first 2 terms, assign that as A and B. A is x and B is 2x. Okay.
Okay.
So just change them. Cos x minus 2x will give you cos minus x, and x plus 2x will give you cos 3x.
Okay.
So sin x sin 2x has changed into 1 by 2 cos x minus cos 3x. Okay.
Okay.
And you do have the third term in your question, which is sin 3x. So now you can take the sin 3x and you can multiply with these 2 terms. Cos x into sin 3x is cos x into sin 3x. Cos 3x into sin 3x is cos 3x into sin 3x.
Okay.
We are just multiplying inside. Okay. So again we'll be performing the same thing. Like you have to write the formula for cos A sin B.
Okay.
And cos A sin B. Just the values will differ. So what is cos A sin B? Cos A sin B is
sin A plus B.
Cos A sin B or sin A cos B, whatever. Sin A plus B plus sin A minus B upon 2, because multiplication is commutative. It doesn't matter.
Commutative.
Okay.
Okay.
So you can change this into, to avoid confusion, like just change it into sin 3x into cos x dx. So A is going to be 3x and B is going to be x. Clear? And this question also. A is going to be 3x and B is going to be 3x. The same formula, but the value of A and B differs. So after converting into the sum of the formula, you can do the normal integration. That's it.
Okay.
Question number 7. This question is also, it contains product of the terms. There are 2 sine terms, sine 4x and sine 8x are in multiplication. Change it into the sum of the formula and then you perform the integration.
Okay. Yes.
1 minus cos x upon 1 plus cos x. Okay. So 1 minus cos x can be written as 2 sine square x by 2. And 1 plus cos x can be written as 2 cos square x by 2. Okay. So we are just trying to simplify this. So now you just substitute 2 sine square x by 2 and 2 cos square x by 2. 2 and 2 will cancel out each other. Sine square theta upon cos square theta can be written as excuse me, tan square theta. There is no formula for the integration of tan square theta. So you have to use this
Okay.
identity. Tan square theta
yes,
equal to
yes.
secant square theta minus 1. So here the theta
Yes.
is nothing but x by 2. So when you integrate
Okay.
secant square, the answer is tan square,
Tan square.
isn't it?
Yes.
And the coefficient of
Yes.
x should be written in the denominator. The coefficient of x is 1 by 2, so that you will write it here. And integral
Okay.
1 is nothing but x.
Okay.
Understood?
Yes, ma'am. Yes.
Cos x upon 1 plus cos x. So you're just adding and subtracting 1 in the numerator. Okay.
Okay.
So you are clubbing 1 plus cos x and negative 1 separately. Just keep the negative 1 separately.
Okay.
This 1 plus cos x
Okay.
is common for 1 plus cos x in the numerator and 1 in the numerator. Okay. So we are
Okay.
clubbing like
Okay.
this in order to make the cancellation of these terms.
Okay.
I'm grouping like this. Yeah.
Yes, ma'am.
So integration of 1 is very simple. It's x. And you have 1 by 1 upon 1 plus cos x. 1 plus cos x
Okay.
can be written as 2 cos square x by 2. Keep the 1 by 2 as constant and keep it outside of the integral sign. And cos square x can be written as secant square. And we do have the formula for the secant square. Integration of secant square theta will give you the result as tan theta. So it's
Yes,
tan
ma'am.
x by 2. And what is the coefficient of x? It's 1 by 2. So that you will write it in the denominator. Understood?
Okay, ma'am. Yes. Done, ma'am. Yes.
Sine power 4x. So sine power 4 can be written as sine square the whole square. And we do have a formula for sine square theta, which is 1 minus cos 2 theta upon 2.
Yes.
And here the theta is x.
Yes, ma'am.
So just integrate 1 minus cos 2x upon 2. Integration of 1 minus cos 2x the whole square. Before proceeding the integration, this
Okay.
has the resemblance of the algebraic identity a minus b the whole square. So you can express it in this form. So if you express it, you'll be getting the term like this. And then you perform the integration. Okay.
Okay, ma'am.
Again, like cos 2x the whole square can be written as cos square 2x. And what is cos square theta? Cos square theta is cos 2 theta plus 1 by 2. Just replace just replace theta as 2x here. Okay. So it's cos 2 into 2x, which is cos 4x plus 1 upon 2. Clear?
Okay, ma'am.
So integration of 1 is 1.
Yes, ma'am. Yes.
Integration, I mean 1 is x. Integration of this 1 by 2 can be written as 1 by 2x, and integration of cos 4x is sine 4x by 4.
Okay.
Okay. And this cos 2x can be written as sine 2x upon 2.
Okay, ma'am. Fine.
Can you follow?
Yes, ma'am. Yes.
Same method. We're just rewriting the cos power 4x in terms of cos square the whole square. Okay.
Okay.
Rest of the terms are same. So in the previous question, we saw a minus b the whole square. Here we do have a plus b the whole square. That's it.
Okay, ma'am. Okay. Okay.
Sine square x upon 1 plus cos x. So we are rewriting the sine square x as 1 minus cos square x because in the denominator you do have cos terms. So 1 minus cos square x can be written as 1 square minus cos square x. So a square minus b square can be written as 1 plus cos x into 1 minus cos x.
Okay.
So just replace your numerator like this. In the denominator, you do have 1 plus cos x. Change the 1 plus cos x and 1 plus cos x. Okay. So you're left with 1 minus cos x. So when you integrate this, integration of 1 is x and integration of cos x is sin x. That's it.
Okay.
Cos 2x minus cos 2 alpha upon cos x minus cos alpha. So you are rewriting cos 2 theta as 2 cos square theta minus 1 here.
Okay.
So you are substituting for both the terms in the numerator. Okay. So they are just substituting theta as x in the first term and alpha as the x in the second term. And then this minus 1 and plus 1 cancelled out each other. So we'll be left with 2 cos square x and minus 2 cos square alpha. Take the 2 outside, cos square x minus cos square alpha. And this a square minus b square can be written as a plus b into a minus b, isn't it? So that would give you
Yes,
cos x
yes.
cos alpha into cos x minus cos alpha. So in the denominator,
Okay.
you have cos x minus cos alpha. So
Okay.
cos x minus cos alpha, cos x minus cos alpha will cancel out each other. So you'll be
Okay.
having 2 times of cos x plus cos alpha in the numerator. Clear?
Okay. Yes.
So when you integrate this, integration of cos x is sin x, integration of cos alpha is, what is cos alpha? We are integrating with respect to x. Don't
Dx.
write the answer as sin alpha. Many people tend to do that.
Okay.
Okay. We are
Okay.
integrating with respect to x here. So cos alpha is
X
considered to
here.
be the constant.
Constant.
So it will be,
Yes.
you are integrating
1.
just 1. So that would give you
Yes.
the result as x.
X.
Into
Okay.
cos alpha.
Okay.
Cos x minus sin x upon 1 plus sin 2x. So here we are rewriting the sin 2 theta as 2 sin theta cos theta. And
Okay.
also we are changing 1 as sin square x plus cos square x. So now in the denominator, you do have the structure a square plus b square plus 2ab, isn't it?
Yes, ma'am. Yes.
A is sin x and b is cos x.
Yes.
So now
ma'am.
you can write this as a plus b the whole square. So now you can solve this with help of the substitution method. Just take the sin x plus cos x as t. Differentiate it and change your question. Cos x minus sin x and cos x minus sin x will cancel out each other. You'll be left with t power 2 in the denominator. Take it to the numerator. It will become t power minus 2. Use the power rule for the integration. It will become t power minus 2 plus 1 upon minus 2 plus 1, which is t power minus 1 upon minus 1.
Okay.
Which can be written as minus 1 upon t. We know the value of t. Putting the value back, you will be getting minus 1 upon sin x plus cos x plus c. That's it.
Okay, ma'am. Okay.
Tan cube 2x into secant 2x. So we don't have any formula for the integration of tan square or tan cube theta. We can split the tan cube theta as tan square theta into tan theta. Just rewrite tan square theta as secant square theta minus 1. That's what we are doing.
Okay.
Over here. Okay. So now we can do the substitution method, because when you choose secant theta as t, differentiation of secant theta will give you the result as secant theta tan theta, isn't it?
Yes, ma'am. Yes.
Secant theta tan theta, and here you do have theta as 2x. So by using chain rule, when you differentiate 2x, again you will be having 2.
Okay.
Understood?
Yes, ma'am. Yes.
I'll do it here. Differentiation of secant theta is secant theta tan theta, isn't it? I'm assuming theta as 2x here. So we'll be having secant 2x tan 2x. And by using chain rule, what is our assumption? The assumption is 2x. So you have to
2x.
differentiate your assumption and multiply with your answer. So differentiation of 2x will fetch you the result as 2 only. So it's 2 into secant 2x into tan 2x. Got it? That is why we are having this result in this way.
Okay.
So from this, you can write dx as dt upon 2 secant 2x into tan 2x. Clear?
Okay. Yes, ma'am. Very clear.
So now just replace the questions in terms of x. Secant square 2x can be written as t square minus 1.
Okay.
Yeah. Just write tan 2x as tan 2x itself. And what is secant 2x? It's t. And what is dx? Dx is dt upon
dt divided 2 secant 2x
tan 2x. Tan 2x and tan 2x will cancel out each other.
Yes.
This secant 2x can be written as t. This t and this t will cancel out each other. Take the 1 by 2 outside, you will be left with 2 t square minus 1 into dt. Understood?
Yes, ma'am. Okay.
Integrating this is very easy. Integration of t square is t cube by 3 and integration of 1 is t.
1 is minus x.
Just substitute the values back.
Okay, ma'am. Okay.
That's it. It's secant cube 2x upon 3 minus secant 2x.
Okay.
That's it. Again, this question, you're just substituting the value of tan square theta in terms of secant square theta. Okay.
Yes. Yes.
So here we are splitting them. We are splitting them into two terms and we are integrating separately. The first one can be integrated by using the substitution method. Assign tan x as t and do the differentiation. Okay, you'll be able to differentiate it. And for the second term, you do have integral tan square x. Again, you don't have any formula for tan square. So we have to convert tan square as secant square minus 1. So now you have to integrate secant square. Integration of secant square x is nothing but tan x. Integration of 1 would give you the result as x. That's it.
Okay.
At last, you have to club the I1 and I2.
Okay. Done.
Sin cube x plus cos cube x upon sin square x plus cos square x. Okay. So they are just splitting it. The denominator sin square x cos square x is common for sin cube as well as to the cos cube. So when you split them, the sin cube and sin square will cancel. The sin cube will deduce to sin, isn't it? This cos square and cos, if you cancel out each other, then the numerator will turn into cos. Okay?
Okay.
And again, this cos square x can be expressed as cos into cos. Sin by cos can be written as tan. Similarly, this cos upon sin square x can be written as cos upon sin into 1 upon sin. Cos upon sin can be written as cot theta. And 1 upon sin x can be written as cosecant theta. And 1 upon cos x is nothing but secant. Yeah?
Okay.
And what is integral secant tan? Integration of secant x tan x, that is a formula. The answer is secant x. And integration of cot x cosecant x is also negative cosecant x. Okay? By Hardy's formula.
Okay.
Okay. So this question, we are just expressing the cos 2 theta in terms of 1 minus 2 sin square theta. After that, this negative 2 sin square x and plus 2 sin square x got cancelled. 1 upon cos square x can be written as secant square x. You know how to integrate secant square, which is tan x. That's it.
Okay.
Again, this question. They are rewriting 1 as the identity sin square theta plus cos square theta. They are just splitting it because this denominator is common for both the terms. Split the fraction. Like a plus b by c can be written as a by c plus b by c, isn't it?
Okay.
So now we can make the cancellation. This sin square x, this sin x and sin x, this cos square x and cos cube x contains cos square x into cos x. So that can be cancelled. Simplify.
Okay.
You'll be left with this.
Okay, I'm done.
So further simplify. Write the cos cube as cos square into cos. So you'll be having 1 by cos square here and 1 by cos square here as well. Take the 1 by cos square as common. You'll be left with sin x upon cos x plus cos x upon sin x. This can be written as tan and this can be written as cot. 1 upon cos square x can be written as secant square. And they are rewriting cot theta as 1 upon tan theta. Okay. So now they are going to use the substitution method. Assume tan theta as t. When you differentiate tan theta, you will be getting the result as secant square theta. This t will turn into dt by dx. So dx can be written as 1 upon secant square into dt. Yeah. So now let's make the changes. It will become t plus 1 upon t into secant square x. And what is dx? Dx is dt upon secant square x. Secant square x will cancel out each other. You will be left with t plus 1 upon t dt. Split them by using the distributive rule. So integral t dt plus 1 upon t dt. Integration of t is t square upon 2. Integration of 1 by t is log t.
Log t. Yes.
Clear?
Yes.
And again, you have to substitute the value of t, which is tan x. So it will become tan square x upon 2 and log of t will be log tan x.
Okay.
Okay. Cos 2x upon cos x plus sin square x. Cos 2 theta can be written as cos square theta minus sin square theta. So again, you can split this using a square minus b square, which is a plus b into a minus b. Here a is cos and b is sin. Okay. So This one and this one can get cancelled out each other. You will be left with this. Take this as t and do the differentiation and use the substitution method. You'll be able to get the solution. It's pretty simple.
Okay.
Remaining questions are substitution method only. We'll move to the next exercise.
Okay.
Okay, just a second.
Yes.
Okay, exercise 7.4, question number 1. 3x square upon x power 6 plus 1. So
Okay.
again, we are going to integrate this using the substitution method. Okay, let's rewrite the question as 3x square upon x cube the whole square plus 1. Okay.
Okay.
Because when you integrate x power 3, you will be getting the answer as 3x square. For that purpose, we are just changing the x power 6 into x cube the whole square. Clear?
Okay.
So I'm assuming
Yes,
x cube as t now, and when I differentiate both the side, and I'll be getting 3x square on the left side, and the right side it's going to be dt by dx, and we can write dx as dt upon 3x square. Clear?
Okay, ma'am. Okay.
So now let's change the question in terms of t. So they made the changes over here. So it's 3x square upon x cube the whole square plus 1 into dx. And what is 3x square? Just write 3x square as 3x square itself, and x cube the whole square is nothing but it is t square plus 1. And what is dx?
Yes.
It's dt
dx
upon
is
3x
dt by
square,
3x
isn't it?
square.
Yeah.
Yes.
So this 3x square and this 3x square will cancel out each other. You'll be left with dt upon t square plus 1. T square plus 1. And this 1 can be written as 1 square. We do have a formula here. That is when you, the integration of 1 upon t square plus a square can be written as 1 upon a tan inverse of t upon a plus c. Okay. Here a is nothing but 1. The constant term is considered as a. The variables are considered as t here. Okay. So t is t and a is 1. Just replace a as t in this. I mean, just replace a as 1 in this. So it will become 1 upon 1 tan inverse of t upon 1 plus c. So 1 upon 1 is 1 only. Tan inverse of t by 1 can be written as tan inverse of t. Again, substitute the value of t as x cube in this. Tan inverse of x cube plus c is the answer. Got it?
Okay. Yes, I'm got it.
1 upon square root of 1 plus 4x square. So now, you just see whether do you have any coefficient with x square. Okay. Take that coefficient outside. Okay. So here you are integrating with respect to x. Okay. So the coefficient of x square should be taken outside. So when you take 4 outside, this 1 will turn into 1 upon 4. And 4x square will turn into x square. Okay. So now you can change this 1 upon square root of 4 can be written as 1 by 2, isn't it?
Yes, sir.
And 1 by 4 can be written as 1 by 2 the whole square. Can I do that?
Yes, ma'am.
1 by 4 can be written as 1 by 2 square, and 1 by 2 square can be written as 1 by 2 the whole square. Okay. So here you have a formula. 1 divided by square root of x square plus a square. See, in the first question, we didn't have square root. That is the only difference here. We had the answer in the form of tan inverse. Okay. So in the question number 2, we have the same expression x square plus a square in the denominator, but we have square root here. Okay. So square root of x square plus a square. Whenever you have this form, you have to express the answer as log of x plus square root of x square plus a square plus c. Clear?
Okay. Yes.
I already told you a means it's constant. So the value of a going to be 1 by 2 and x is 6.
Okay.
Okay.
Yes.
So it's going to be log of x plus square root of x square plus a square. A square is 1 by 2 square.
Okay.
Clear?
Yes, ma'am. Yes.
And 1 by 2 square can be written as 1 by 4. And they are taking LCM here. LCM and simplify. And square root of 4 is nothing but 2. Again, they are taking LCM. Log of a by b can be written as log a minus log b. So log of 2x plus square root of 4x square plus 1. This is a and this is going to be b. So just write it in this way. Take the 1 by 2 to the other side.
Okay.
That's it.
Okay.
Clear?
Yes, ma'am. Very good.
1 divided by square root of 2 minus x the whole square plus 1. So 2 minus x is t.
Okay.
Substitution method. Okay. So differentiate both the
Okay.
side. X will turn into -1. T will become dt by dx. And dx is equal to minus dt, isn't it? So this dx will turn into negative dt. How can I rewrite? It will be t square plus 1 into minus dt, isn't it? This is how my question will change.
Yes.
Take the minus outside. It's minus dt upon square root of t square plus 1. You can write 1 as 1 square. Again, the same form. Log of x plus square root of x square plus a square. Here a is 1 and x is t. That's it. Clear?
Yes.
Just replace t as 2 minus x in this.
Okay.
This question. This is also pretty simple. I already told you. Since we are integrating with respect to x, you just have to take the coefficient of x square outside. Here the coefficient of x square is 25. Take it out. 9 will turn into 9 upon 25. 25 x square will turn into 25. So this 9 upon 25 can be written as, how can you rewrite in the form of square? 9 is the square of 3 and 25 is the square of 5, isn't it?
5.
So you can write it as 9 by 25 can be expressed as 3 by 5 the whole square.
Okay.
So here now, if you look at the structure, the denominator contains a constant square and then you have a variable square. It's a square minus x square. If it is of this form, you have to write your answer as sine inverse of x by a. Okay. So x is x here. A is 3 by 5 here.
Okay.
Just replace a as 3 by 5 in this. So it's going to be sine inverse of x upon 3 by 5. Denominator to the denominator can be taken to the numerator. It will turn into sine inverse of 5x upon 3. Clear?
Okay.
So you just have to by heart this form. This is very important. So what is dx upon x square plus a square? What is dx by square root of x square plus a square? What is dx by square root of a square minus x square? Okay. So knowing the general form is very important.
Okay.
So this question again. So this question they are directly differentiating it. They're just rewriting 2x power 4 as 2x square the square. Okay. They are taking x square as t and they are performing the substitution method here.
Okay.
So at last you get this term t square plus 1 by root 2 the whole square, a variable square and a constant square. There is no root.
Okay.
So without root, it is 1 by a tan inverse of x upon a formula. So x is t here and a is 1 by root 2. 1 by 2 can be written as 1 by root 2 the whole square, isn't it?
Yes, ma'am. Yes.
This x power 6 can be written as x cubed the square. Again, go for substitution method. Okay, I'll do this one by one. So you have x square upon 1 minus x cubed the whole square. Okay. So let's x cube equal to t. When you differentiate both the side, x cube will turn into 3x square and t will turn into dt by dx. Dx can be written as dt by 3x square. So now let's change our question in the form of t. So just write x square as x square itself. 1 minus x cubed the square can be written as t square. And what is dx? It's dt upon 3x square.
3x square.
Just cancel out x square and x square. So we'll be left with dt 1 by 3 1 minus t square. Got it?
Okay. Yes, ma'am. Got it.
Can I write 1 as 1 square?
1 is 1. Yes, ma'am. You can write.
So you can write dx upon a square minus x square formula now. It is in this form.
Yes. Yes, ma'am. Yes.
So what is a square minus x square? It's 1 by 2a log of a plus x upon a minus x. That is the formula.
Okay.
Okay. So if you compare this, you can write a as 1 and t as x. Isn't it?
Yes, ma'am. Yes.
So just replace a as 1 and x as t in this.
Okay.
So it will be 1 divided by 2 into a, which is 2 into 1 log of a plus x. So 1 plus x upon I mean, x is t, right? So it's 1 plus t upon
Yes.
1 minus t.
Okay.
Clear? 1 by
Yes,
3 into 2
ma'am.
can be written as 1 by 6.
Okay.
X minus 1 upon square root of x square minus 1. The square root of x square minus 1, the denominator is common for both the terms. Split them.
Okay.
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 So let's solve it separately. Assume this is integrand 1. X upon square root of x
Okay.
square minus 1. Take the expression, take the equation in the denominator. Assume that is t.
Okay.
Differentiate both the sides. We'll be having 2x in the left side, and the right side it's dt by dx, and dx can be written as dt by 2x.
Okay, ma'am. Okay.
Just a second. So now, just putting the values, you can say x upon square root of t into dt upon 2x. Just a second.
Yes.
Hello. சொல்லுங்க ஷனிகா. சொல்லுங்க. Just a second.
Okay.
It's for 90 actually.
Okay, அக்கா. அக்கா.
சொல்லுங்க.
இப்பதான் அக்கா.
ம். Hello.
Yes, ma'am.
Where were we? இங்க தானடா பார்த்துட்டோம்.
ஆமா ma'am. Yes.
Okay. So integration of x upon square root of x square minus 1 dx can be written as x square minus 1 can be assumed as t, and when you differentiate both the side, 2x is equal to dt by dx. So dx is equal to dt upon 2x. Okay.
Okay.
So dx can be written as dt by 2x, and you have x here and square root of t. X and x will cancel out each other. You will be left with 1 upon 2 into square root of t. Okay. So write square root of t as t power 1 by 2. Take it to the numerator. It will become t power minus 1 by 2. So when you integrate, t power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 will become t power 1 by 2 upon 1 by 2. Okay. So t power 1 by 2 can be written as square root of t. And what is t? T is x square minus 1. Putting back. Okay. So let's solve the integral 2. It's 1 upon square root of x square minus 1. And 1 can be written as 1 square. Yeah. So x square minus 1 square. Why have we used plus here? Just a second. It's minus only, right? Yeah, it should be minus only.
Okay.
Just a second.
Yes, ma'am. Should be minus.
It should be minus. Yeah. So use this formula. Substitute x as x and a as 1.
Okay.
That's it.
Okay. Okay.
So x square upon square root of x power 6 plus a power 6. Just rewrite x power 6 as x cube the whole square. Okay. X cube the whole square. And you can write a power 6 as a power 3 the whole square.
Okay.
So we are assuming x cube as t here. And when you differentiate, dx can be written as dt by 3x square. So we are just changing our question in terms of t. This x square and this x square will cancel out each other. You will be left with this. So square root of t square plus this a square can be written as this form.
Okay, ma'am. Okay.
Understood?
Yes, ma'am. Yes, got it.
Secant square x upon square root of tan square x plus 4. So we are taking tan x as t and we are differentiating it. Differentiation of tan x is secant square x. We already know that.
Yes, ma'am.
So this secant square x and this secant square x will cancel out each other. It will be 1 upon square root of t square plus 4. 4 can be written as 2 square. And we know the formula for t square plus a square, which is log of x plus square root of x square plus a square. Okay, the same.
Yes, ma'am. Yes. Okay.
So you have a quadratic equation underneath the square root.
Okay.
Okay, so this is completion of the square method. You remember?
Yes, ma'am. Yes. Adding and subtracting. Yes.
Subtracting. Like what do? You just have to take the first two terms. You do have x square plus 2x here. So you have to assume this as a square plus 2ab. Okay. And you know the formula a plus b the whole square is a square plus b square plus 2ab. So a square plus 2ab can be written as a plus b the whole square minus b square.
Yes, ma'am.
Okay. So let's assume a square is x square and a is x.
Okay, ma'am.
And what is 2ab is 2x. So 2 and 2 can get cancelled. And we know a is x. And from this we can say the value of b is 1. Do you understand?
Okay. Yes, ma'am. Yes.
So we are just going to rewrite a square plus 2ab as a plus b the whole square minus b square form. So what is a plus b the whole square? It's x plus 1 the whole square and minus 1
Whole
square.
square. Yes, ma'am.
So x square plus 2x is equivalent to x plus 1 the whole square minus 1. Can you follow?
Yes. Yes, ma'am. Yes.
Another question. Square root of x square plus 2x can be written as x plus 1 the whole square minus 1. You have plus 2 here. Write that over here. Clear? Now this minus 1 and plus 2 can be simplified. What is minus 1 plus 2? 1 upon square root of x plus 1 the whole square and plus 1, isn't it? And 1 can be written as 1 square.